Hello, welcome to this quick video on how to manage Datadog monitors through Kubernetes configuration. My name is Sara Pulido, that's my Twitter handler, so if you want to reach out, feel free to do so or put a comment on the video. So today we are going to be talking about how to be able to manage Datadog monitors, which are basically the alerts that we create at Datadog, as any other Kubernetes object in your cluster. And we are going to be discussing that this comes a little bit from things like infrastructure as code. Infrastructure as code is a concept where you manage your cloud resources, so your instances, your VPCs, your load balancers, etc., as code. Instead of clicking on the UI of your cloud, where you can lose changes, you don't know what changes did you really make, you store everything on a text file, and you use tools like CloudFormation or Terraform to apply those to your cloud. So this is becoming very, very popular and allows you to replicate your environment very quickly and to make sure that you have a track of what's going on. Similar to that, this configuration as code. Configuration as code is the concept of your application configuration also as a text file that your team can review, you can store on Git, and things like that. So you can replicate your environment very quickly. In Kubernetes, this makes a lot of sense because the configuration of your application is going to be your YAML file where you define your daemon set, your stateful sets, your deployments, etc. So Kubernetes makes it very, very easy to adopt configuration as code. An evolution of this is something called GitOps. GitOps basically is the same thing as configuration as code and infrastructure as code, but with a twist. So the twist of GitOps says that everything that you want to change in production, you change it first, committing it to Git. So Git becomes, your Git repository becomes the real source of truth. And whatever you have on your Git repository, it's going to be replicated in your production environment. So the way you do that, or the way it's recommended to do that in GitOps, it's by anytime that you want to make a change, you create a PR, your peers review it, you commit it to Git, and then is your production environment, in this case in Kubernetes, your cluster, which is going to see that there is a change in Git that doesn't match what is running in production, and it's going to apply the needed changes to make that reconciliation loop. And there are tooling like Flags. Flags is a CNCF project that is very popular that does exactly this. So it creates this reconciliation loop in your cluster that is going to check any changes that are happening in Git, and it are going to apply those. So this is great in Kubernetes. I really recommend following this pattern, have everything in Git, apply those changes either with the tooling or something else, but really make Git your source of truth. So now that we have configuration as code and maybe also infra as code, what about observability? Can we have our monitors? Can we have our dashboards? Everything that we care about our observability strategy, can we have it in Git as well? So Datadog provides a Terraform provider, so you can store many of the things as Terraform files. There is also an API, but when you're using Kubernetes, probably your configuration of your application is on YAML files, as we said. So it kind of makes sense that could be a way to store your alerts, your monitors, alongside those Kubernetes YAML files. Why? Because the people who are creating those configurations are probably the application developers who understand very clearly what you want to alert on for that application. And that is what DatadogMonitor tries to achieve. So DatadogMonitor is a new Kubernetes object, a new CRD as we call it, where you can define the alerts that you want to create for your system or your applications and store them alongside the rest of your Kubernetes configuration. So let's check a demo. So this is the demo environment. This is a cluster. So as every other video we create, we try always to create one of these lab environments for you. So two things: if you want to give this a try, you don't have to create your own Kubernetes cluster because this is basically a 2-node Kubernetes cluster. And you don't have to create your own Datadog account or use your company's Datadog account, because when you spin this up, you're going to get some credentials, a username and a password for an account that is temporarily created for you. This is the account that was created for me. Good. So the first thing that we need to do is to deploy the Datadog agent so we can start monitoring this cluster. And the way we are going to deploy the Datadog agent is by using also quite a new feature called the Datadog operator, which is basically an operator that is going to run in your cluster, and then you can create things like a Datadog agent or this new DatadogMonitor. So if you want to use this new CRD object called DatadogMonitor, you need to deploy the Datadog operator first. So we have another video and another scenario for how to use the basics of the Datadog operators. I'll put a link as well, so you can use that as well. So because we already have the API key and app key of that account, just clicking here, it's going to install the Datadog operator. We are going also to install kubestate metrics for some Kubernetes metrics. So once we do that, we can see that we have here the Datadog operator running, which is basically what we needed. If we get as well the CRDs that were created as part of that Helm install, we see that we have Datadog agents, Datadog metrics, and Datadog monitors. Datadog monitor is the one that we are going to be covering today. Cool. So now that we have that installed, we can see that there were also a couple of secrets that were created as part of the Helm install with our app key and API key for our accounts. So that's already there. So the first thing we are going to do is to deploy the Datadog agent. So as you know, in order to monitor your cluster, you need to run a daemon set in every node that you want to monitor, so we can collect all those metrics. So this is what we are doing here. Again, because we are using the Datadog operator, there is a new object, a new CRD called the Datadog agent that makes very, very simple deploying the agent. So in our case, we are passing the API and app key. We are setting up APM, and we are also setting up process logs, etc. We are also deploying the cluster agent to collect Kubernetes API metrics. Cool, so let's apply that configuration. When you apply that configuration, it creates a new Datadog agent object. And this is the object that we have created. You can see that it's not yet active because we just created. The deployment is progressing. So every time that you see this progressing, you can wait a little bit until it sets running. Same thing with the cluster agent. And the way this relates what we're running here, we have the Datadog agent daemon set. So basically we have one for each node, and we also have the cluster agent running. So they're progressing very nicely. So let's wait some seconds until this is fully running. So if now we do again get the Datadog agent, you can see that it's running already, even though one of them is not ready yet, but it's going to be ready very soon. So now that it's running, we can run the Datadog agent status that we've seen several times, where you can see, for example, the the checks that are running on your system to make sure that everything is correct. The kubelet check, very important for our Kubernetes cluster, because it gets all the metrics for our containers is up and running correctly. So we should be good to go. So let's move on. Cool. So let's create our first monitor, and we are going to start by creating one for our system metrics, for our nodes. We are going to put ourselves our ops hat, and we are admins of this cluster, and we want to make sure that the disk doesn't get full. The reason is why if it gets full, it affects the scheduling of your pods. So to do that, we are going to help us create that query. We need to create a query of what we want to alert on. And a very easy way in Datadog to play and get those queries right is using, for example, a notebook. A notebook allows you to create all these areas of information that then you can save, or you can delete, you can do whatever you want. Notebooks are very popular for example, to have post-mortem documentation after the incident. So we have here, and we are going to change to the metric that we care about, which is basically system disk in use. We are going to select this metric. We can see here our nodes are starting to report. And we are going to say that we want that by host. So we want to make sure that at any point, none of our nodes get over 50% capacity on disk. So once you've created that, you can copy very easily. You can copy that query and you can reuse it. So we are going to copy that. And now we have to create that object, the DatadogMonitor, and we have already started creating it for you. You can see this is the type of object that we need to do to create those monitors in as code and to store those with the rest of our Kubernetes configuration and our application configuration. So you can say that it's just like a normal Kubernetes object where you have the kind of the object, which is DatadogMonitor, a name, and a set of metadata that we need to create that monitor. The only missing piece, if you run this by yourself, it's the query. But now we have copied the query. Cool. We have to add a couple of things to this query. First, basically, here we are only say the metric that we care about. We need to say when we want to alert. And we want to alert once it goes above 50%. So this is our query. And also we want to alert only if this happened for the last 10 minutes. And this is very useful when you create monitors to avoid for metrics that have a lot of variance in a very short of time. You don't get alert fatigue by getting too many alerts. So basically we're saying here, we want to get alerted if any of these hosts goes about 50% of their disk capacity, but only if it happens for 10 minutes. Cool, we have this object not ready, so we are going to apply this one. Again, if you run this environment yourself, you can see that clicking on any of these commands is going to basically write the commands, so you don't have to type all the time. Once you have applied, again, as any object that happens in Kubernetes, it will have, you can do kubectl get the type of the object, and it's going to be there. So it has created it. Right now it has no data because obviously it needs a little bit of time to gather those metrics. But even if it doesn't have any data, if you go to your monitor section on here, you can see that now you have that monitor up and running, which is what we wanted. And you can start creating this. Cool. So now you can start monitoring that yourself, which is great. Now we have a monitor for our nodes. Let's do something a little bit different. We want to also monitor an application. So if you run this yourself, you can see that we already have an application up and running. This application is an e-commerce application. It has a front-end monolith service, and it has a couple of microservices, one to get discounts, one gets ads, all backed up by a Postgres database that is also running in our cluster. So this is all running already for you, and it's already instrumented for distributed tracing as well. So anytime that we create a request to this particular application, it's going to create a trace and it's going to send that trace to Datadog. And if we check this namespace, fake traffic, traffic, you can see that there is a pod that is creating regular traffic to an application, so we make sure that we have enough data. So if we go to our APM section now, you can see here that we're already getting those traces. And because we are getting those traces, we can see that we get the ads, discount, Postgres, and front end. Not sure if this is ready, might be ready or not. We have here as well this application. Cool. So let's imagine that we want to make sure that the ad service error rate doesn't go over 1%. Let's imagine that that service is very important for the revenue of our company, and we want to make sure that if errors happen, it doesn't happen more than 1% of the requests. So how do we do that? Let's do the same thing to create the query. So let's start by a blank notebook to help us elaborate that query in an easier way. And basically what we are going to do is to say, okay, we want to create trace. These metrics are generated by distributed tracing. So the request hits for our ad service, and only the ones that are successful. And then we create another query that basically it's the same thing, but for all of them. And now we divide these two. So we want to make sure that basically if we want to keep the error rate below 1%, we are doing things the other way around. We are going to say that the successful requests that we want have to be over 99%. So this is our query. Let's copy that and let's open this file again that we have created for you. That it's a little bit different. The only thing that we've changed is we've put a new tag for the service, so we can track very easily that this is for the advertisement service. We copy this, and again, we need to make sure that this is less than 99% of the requests. We are doing the other way around. And same thing that we did before, we want this to alert only if the error rate over 1% lasts for about a minute. So again, to avoid just transitional errors that may happen for whatever reason, networking, etc. So once you've created that, we apply this object. And once we applied same thing, we have this new monitor. And if we go now to our monitor sections, we can see that we have here this new monitor that will alert us if our error rate of our ad service goes above 1%. And again, the good thing about this is that you can store this with the rest of your ad service configuration, and your team, who are the ones who understand when to alert, can store those two things together. And if they make a change to the ad service to improve its reliability, and they want to make sure that the error rate decreases even more, they can also change that as part of the same PR. So you can create a PR saying, okay, I've made a change to my ad service to improve its reliability. I can change the configuration for my Kubernetes deployment. And I also can change at the same PR and review it all together, the alert that goes with it. So very nice way to make, and we can see here now that it already getting data, and that's why it's getting green, because right now we are not getting errors. Good, so that's it for today. I'm going to put a link on the video as usual, as always, so you can follow this yourself. Just a recap, we've seen how to create a DatadogMonitor object that creates an alert for your host. And then we've changed our hat to application developer, and we created a DatadogMonitor using Kubernetes configuration for your application. Thanks again for watching, and see you in the next one.